Welcome to the Basic Mathematics. The geometry. The circle. And its 10 theorems. The circle. A circle is a closed-shaped round figure in a plane, the points of which are always at same distance away from a fixed central point. To understand the circle, draw a line from a fixed point O. From the same fixed point O, draw few more lines of same length in the other directions. Continue to draw lines further in all the directions. Now focus on the end points of the figure. This is a circle. The circle, the center. All the points on the circle are at same distance from a point called the center. The circles, the radius. The distance from the center to any point on the boundary of the circle is called the radius of the circle. The circles, the diameter. A line segment with two endpoints, A and B, on the boundary of the circle, passes through the center, O, of the circle, is called the diameter of the circle. It can be seen that the diameter is twice the radius, or diameter D equals 2 times radius R. The circles, the circumference. Point P to point P is the circumference of the circle. The circumference is the linear distance of the total boundary of the circle. It is same as the perimeter of any other closed geometric figure. The length of the circumference depends directly on the diameter of the circle. Circumference C directly proportional to the diameter d. C equals pi times d, where pi is a constant of proportionality. We demonstrate to you how the length of the circumference depends directly on the diameter of the circle. It is impossible to find the exact value of pi. It is an irrational number. Value of pi is approximated as 22 divided by 7 or 3.14. Circumference C equals pi times d equals 2 pi r. The circles, the chord, a line segment whose endpoint lies on the circle circumference is the chord of the circle. The longest chord of the circle is the diameter of the circle. The circles, the secant, an intersecting line at two different points of the circle is known as the secant of a circle. The secant is the extension of the chord going outside the circle. The circles, the tangent, a straight line that touches the circle, intersects the circle only at one point of the circumference, is called the tangent of the circle. The tangent of a circle never enters the inside the circle. The tangent and the point of tangency, the only point where straight line intersects or touches the circle, is called the point of tangency. The point P is a point of tangency. The properties of the tangents are: number 1. A tangent touches the circle only at one point of the circumference. Number 2. The tangent of a circle never enters the inside the circle. And, important 1. Number 3. The diameter of the circle at the point of tangency makes right angle with the tangent. The circles, the arc, a part of the circumference, or a segment of the circumference of the circle, is known as the arc. The circles. The sector. A part of the circle, made of the arc and two radii, is called sector of the circle. Its one vertex is the center of the circle. The circles. The segment. The segment of the circle is made of the arc and a chord. Larger part is major segment, and smaller part is a minor segment. The circles. The inscribed angle of the arc or the chord. An inscribed angle of a chord or of an arc in a circle is an angle whose vertex lies on the circumference of the circle. The angle APB is an inscribed angle of the chord AB. The circles. The central angle of the arc or of the chord. A central angle of a chord or of an arc in a circle is an angle whose vertex is the center of the circle. The angle ACB is an central angle of the chord AB. Please note here, the central angle of the minor arc AB is acute angle. The central angle of the major arc AB is obtuse angle. If arcs are equal, it makes semicircles, or it divides the circle in two equal parts or semicircles. Semicircle's chord is the diameter, and central angle is 180 degrees. The central angle of 1 radian. 1 radian is the measure of the central angle, whose arc length is the same as the radius of the circle. Total central angle 2 pi or 360 degrees. The central angle of the circumference is 2 pi radian or 360 degrees. Relating the radians to the degrees, 2 pi radian equals 360 degrees. 2 by 3.14 radian equals 360 degrees. or 1 radian equals 57.295 degrees. The circle theorems. The circle theorems. Number 1. The angle at the center of a circle is twice the angle at the circumference subtended by the same arc. The circle theorems. In other words, on a common chord, or the arc, the central angle is twice the inscribed angle. If angle APB equals theta, then angle AOB equals 2 times theta. To prove, draw a line from the center O to the point P, the vertex of the inscribed angle, on the circle. Let the angle PAB equals alpha and the angle PBO equals beta, and we know the sides AO equals OB equals OP equals R, the radius. Now focus on the triangle BOP. The triangle BOP is an isosceles triangle, as sides BO equals OP equals radius R. Therefore angle OPB equals angle PBO equals beta. Therefore angle POB equals 180 minus beta equals 180 degree minus 2 times beta. Now focus on the triangle AOP. The triangle AOP is an isosceles triangle, as sides AO equals OP equals radius R. Therefore angle OPA equals angle PAO equals alpha. Therefore angle POA equals 180 degrees minus alpha equals 180 degree minus 2 times alpha. Now focus on the angles at the center as vertex. Therefore angle POA plus angle AOB plus angle BOP equals 360 degrees. Therefore angle AOB equals 360 degrees minus angle POA minus angle BOP. Therefore angle AOB equals 360 degree minus 180 degree minus 2 times alpha minus 180 degrees minus 2 times beta. As alpha plus beta equals theta, therefore angle AOB equals 2 times theta. Hence theorem is proved. The circle theorems. Number 2. The angles in the same segment of a circle are equal. The circle theorems. Understand the theorem first, which states that the angles in the major segment of the circle, bounded by the chord AB, as per theorem, so the angle AP1B equals angle AP2B equals angle AP3B equals angle AP4B equals theta. In other words, the inscribed angles of the chord AB are same on any point the circle. From the theorem number 1 of a common chord or the arc, the central angle is twice the inscribed angle. If angle APB equals theta, then angle AOB equals 2 times theta. For the chord AB, there is only one central angle, that is angle AOB, irrespective of the inscribed angle at any point on the circle. As the central angle is always twice the inscribed angle, if angle AP1B equals theta, then central angle AOB equals 2 times theta. If the central angle is 2 times theta, then all the inscribed angles will be equal to the half of the central angle, that is theta. Hence proved the theorem that the inscribed angles of the chord AB are same on any point the circle. The circle theorems. Number 3. the angle subtended by a diameter at the circumference is equal to a right angle. The circle theorems. Now try to understand the theorem which states the angle subtended by a diameter at the circumference is equal to a right angle. From the theorem number 1 of a common chord or the arc, the central angle is twice the inscribed angle. If angle APB equals theta, then angle AOB equals 2 times theta. Please note, in the semicircle, the central angle is 180 degrees. So any inscribed angle from AB, or in semicircle, at a point P on the circle, will be half of 180 degrees. That is right angle 90 degrees. It is interesting to note if a circle circumscribe a right-angled triangle, then the hypotenuse of the triangle will be diameter of the circle. The circle theorems. Number 4. The line joining the center of the circle and the center of the chords is perpendicular to the chord. The circle theorems. Number 4a. The line joining the center of the circle and the center of the chords is perpendicular to the chord. Number 4b. The perpendicular from the center of the circle to a chords bisects the chord. Second statement of the theorem is the reverse of T. The first statement of the theorem. To prove, join the midpoint C of the chord AB to the center O of the circle. Also join center O with the endpoints A and B of the chord. Note: the line segments AC equals CB. It forms two triangles, triangle OAC and triangle OBC. Note: in the triangle AOB, the sides OA and side OB are the radius of the circle, and so OA equals OB equals R radius. It makes this triangle AOB an isosceles triangle. Hence the angle OAC and angle OBC are equal. Next, we focus on triangles AOC and OBC. Comparing triangle OAC and triangle OBC. Sides OA equals OB equals R. Sides AC equals BC and side OC is common. The triangle OAC and triangle OBC are identical triangle. Hence, angle OCA equals angle OCB, and will be equals 90° or right angle. Therefore side OC is perpendicular to the chord AB. The circle theorems. Number 5. When two chords of a circle intersect, the product of the segment of one chord is equals to the product of the segment of the other chord. The circle theorems. When two chords AB and CD of a circle intersect at S in a circle, the product of the segments of one chord is equals to the product of the segments of the other chord, that is, side AS times side SB equals side CS times side SD. To prove the theorem of intersecting chords, draw line A to D and another line C to B. Now focus on triangles ADS and CBS. Note angle DSA equals angle CSB. Opposite angles. And angle DAB equals angle DCB. Angles on same arc DB. On focusing on two triangles ADS and CBS. As two angles are same in triangles, the third angle will also be same. So the triangles ADS and CBS are similar triangles. As the triangles ADS and CBS are similar triangles, so the sides of these triangles will also in same ratio. Side AS divided by side SD equals side CS divided by side SB. Hence the product of sides AS and SB equals the product of the side CS and SD. The theorem of intersecting chords outside the circle is theorem of intersecting chords valid if the chords meet outside the circle. Let the intersecting chords AB and CD of a circle meet outside the circle at S. Proof of the theorem is similar for chords intersecting outside the circle, as we did for the chords intersecting within the circle. Just focus on the similar triangles ASD and CSB. We find sides AS divided by side DS equals side CS divided by side BS. Or the product of side AS and side BS equals the product of side CS and side DS. So, the theorem is also true for the chords meetings outside the circle. Circle theorems of the tangents. Circles and tangents. Please note, two circles can meet each other. Either they touch or intersect. See two circles touch inside the of one circles. Now, watch when they touch from outside, and when they do not touch, they intersect. When two circles meet at one point, then only one common tangent can be made. And intersecting circles have a common chord. Circle theorems. Number 6. When two circles touch at a point, the centers of two circles and point of touching are in one straight line. Understand the theorem first. Centers of two circles O and R and point of touching P are in one straight line. Draw a tangent at the point of contact of two circles. As only one tangent is possible at the point of contact of the two circles, and it will be a common tangent to both the circles. As tangents are always perpendicular to the radius at the point of tangency of the circle, hence it confirms that the line RPO is the straight line. Centers of two circles, O and S, touching inside the one of the circle and the point of tangency T, are in one straight line. As tangents are always perpendicular to the radius at the point of tangency of the circle, and so it is clear that the radius line TS and radius line TO are collinear, and TSO is the straight line. Please note, tangent can be made from a point either on the circle or from outside circle. Two tangents can be made on the circle if the point is outside the circle. Perpendiculars to the tangents at the point of tangency will pass through the center of the circle. Circle theorems. Number 7. If two tangents are drawn to a circle from a point outside the circle, then both the tangents are equal in length. Understand the theorem. First, if two tangents are drawn to a circle from a point outside the circle, then both the tangents are equal in length. The tangent AC is equal to tangent AB. Circle theorems. Number 8. If two tangents are drawn to a circle from a point outside the circle, then the angle between the two tangents is bisected by the line joining point of intersection of the tangent to the center of the circle. The angle between the two tangents, angle CAB, is bisected by the line joining point of intersection A of the tangent to the center of the circle O, line AO. Angle CAO equals angle OAB. Circle. Theorems. Number 9. If two tangents are drawn to a circle from a point outside the circle, then the angle between the radii at the point of the tangency at the center is bisected by the line joining point of intersection of the tangent to the center of the circle. Understand the theorem first. If two tangents are drawn to a circle from a point outside the circle, then the angle between the radii, angle COB, is bisected by the line joining point of intersection of the tangent to the center of the circle, that is line AO, or angle COA equals angle BOA. We will take the proof of all three theorems 7, 8, and 9 together. We focus on triangles ACO and ABO. Note. Number 1. Angle ACO equals angle OBA equals 90 degrees, as tangents and radii are perpendicular. Number 2. Side CO equals side BO, as they are radii. Number 3. Line AO is common side. Triangle ACO and triangle ABO are congruent triangles. Then, side AC equals side AB. Hence prove the theorem 7, that the length of the tangents are equal. To prove theorem 8, again we see triangle ACO and triangle ABO are congruent triangles. Then, angle CAO equals angle BAO, or equals half of angle CAB. Hence prove the theorem 8. Line joining the center and tangent meeting point bisect the angle between the tangents. To prove theorem 9, again we see triangle ACO and triangle ABO are congruent triangles. Then, angle COA equals angle BOA, or equals half of angle COB. Hence prove the theorem 9, line joining the center, and tangent meeting point, bisect the angle between the radii. Circle. Theorems. Number 10. The angle between the tangent and the chord at the point of contact is equal to the angle in the alternate segment This theorem is also called alternate segment theorem. Understand the theorem first. The angle between the tangent and the chord at the point of contact is equal to the angle in the alternate segment. In other words, the angle lies between a tangent and a chord is equal to the subtended angle by the same chord in the alternate segment. Understand the theorem. The angle BAN lies between the tangent TAN and the chord AB. Is equal to the subtended angle APB by the same chord AB in the alternate segment. Or, the angle BAN equals the angle APB equals theta. To prove the theorem, join the endpoints of the chord A and B to the center of the circle O. Angle AOB is the central angle. Angle OAN equals 90 degrees, as tangent and radius make a right angle. Therefore, angle OAB equals 90 minus theta. The triangle AOB is an isosceles triangle. So, the angle OAB equals the angle OBA, and the angle OAB equals 90 degrees minus theta equals the angle OBA. Now again focus in a triangle AOB, and note the angle AOB equals 180 degrees minus the angle OBA, the angle OAB equals 180 minus 90 minus theta minus 90 minus theta equals 2 times theta. Angle AOB is the central angle and equals 2 times theta. Then inscribed angle APB equals theta. equals angle BAN. Hence prove the theorem that the angle between the tangent and the chord is equal to the angle in the alternate segment. Thank you very much for watching. Please subscribe the channel and continue to watch our other videos. Thanks.